Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 6. Today we're going to learn about non-linear regression in machine learning. Let's begin the topic. Non-linear regression is a statistical method used to model relationship where the dependent variable is not linearly related to one or more independent variables. It involves fitting a function to the data that cannot be represented by a straight line. This is a constant to the linear regression, which assumes a linear relationship. So here, what we that non-linear regression is a statistical method used to model relationship between the various when the relationship is not linear, right? So what is unlike the non-linear regression, which assumes a straight line relationship between the dependent variable and the independent variable, right? Okay. So non-linear regression fits a curved function to the data. This curved function cannot take many forms. Okay, example exponential, logarithmic, and logistic, and we can say polynomial, etc. Depending on the nature of the relationship being the modulated. So when to use it, right? Okay, so you can use it as a nonlinear regression when the relationship between your dependent variable and the independent variable appears to be curved, like we have curved, okay, when plotted. So theoretically, suggested or a linear relationship growth curve begins processes, okay, situationally effects. So linear regression models do not fit the data, okay. Most of the show in pattern, low or scored, or despite the clear trend, okay. So it has some key difference, relationships, nonlinear relationship and equations, fitting models. So overall, the nonlinear regression provides a more flexible and more powerful tool for understanding the predicting phenomena where the underlying relationship are more complex, that is simple in a straight line. So nonlinear relationship refers to a broader category of a regression models, right? Where the relationship between the two dependent variables and the independent variables is not assumed to be the linear, right? So which is not perfect. So in is the underlying pattern in the data, it's having a curve, whether its exponential growth decays logarithmically or any other non-linear form. So fitting a nonlinear regression model can provide a more accurate representation of the relationship, right? So this is because in the linear regression, it is a pre-assumed that the data is linear. So we have a linear here regression model can be expressed as, so the equation of y equal to f of x plus beta plus e, right? So here f of x plus beta plus is the regression function, okay? So in the next, x is the vector of the independent variable, which are the used to predict the dependent variable, right? So here beta is the vector of the parameter. That's the model aims to estimate the parameters determines the shape and the characteristic of the regression functions. So here E is nothing but we also know the error of the term. So many different regression existed and can be used to fit where whatever the datasets looks like, such as quadratic, cubic regression, and so on to infinite degrees. Okay, according to our requirement. So assumption that non-linear regression. Okay. So here the assumptions are the similarly to the those in the linear regression, but many have nurtured the interruptions due to the non-linearity of the model. Hence, sorry, here are the key assumptions in a non-linear regression. So what are the functional form? So this is the chosen nonlinear model correctly represented the truly relationship between the dependent and the independent variable, right? So this is the most crucial assumption in the nonlinear regression, right? It means that the specific nonlinear equations or curve you choose to model your data exponential logistic power function must accurately reflect the true underlying relationship. Okay, so between the dependency variable and the independency variable. So next we have independent, okay, observation or assumption to be independent for each other, right? So this observation state that observes the data points in your data sets must be independent of each other. In other words, the value of the one observation should be influenced by the value of the another observation. So it's important because it observes all the non-independent, like example, time series, data set, and auto corrections, auto correlations, and repeated measurements on the same subjects, okay, without any proper handling. So, next time we have the numerarity, residual or assumes it to be a normally distributed, right? So, it is normally of the residual of the parameterly, like we can say that perfect primarily imported for the valid hypothesis testing and the consulting confidence, like for the model parameter, if residential or not normal, okay, it is not normal for the like example, like we can say that the p value and the confidence intervals derived from the model might be not be accurate, while important of our like inference non-nominality of the regency does not necessarily invalid, okay, for the parameter estimates. So simple it's size due to the central limit theorem. So practically we can say that check the assumption, usually check the histogram q plots of the residential, so statically tested. So we have multi-collinearity. So independent variables are not perfectly correlated. Yes, it is in this the independent variable does not meet the linear regression identifying and the same addresses. Multicollinearity is non-linear model can be sometimes be more complex due to the non-linear relationship variance, inflating factors, okay, of the often used detect multicollinearity. So in this overall the case, we are checking that if the necessary address violation of those assumptions is crucial for building the robust and the interpretable nonlinear aggregation model. Ignoring that, then can be lead misleading the conclusions and underlabeled predictions. Okay. So types of the non-linear regression. So we have some few types. So there are two main types of the non-linear regression machine learning. So one of the parametric non-linear regression. So it assumes a relationship between that dependent and the independent variables can be modulated using a specific mathematical function. Okay. So for example, we can take the relationship between the population of the country and the time can be modulated using the exponential function. Some common parametric non-linear expressions like non-linear regressions model includes polynomial regressions, logistic regression, exponential regression, right? Power regression, etc. So another we have two types of non-linear regressive or parametric non-linear regressive, non-parametric non-linear regression. So one is the one. So it does not assume that the relationship between the dependent and the independent variable, right? So it can be modulated using a specific mathematical functions. Instead of it can be machine learning algorithm to be learn the relationships from the data. Some common non-parametric non-linear regression algorithm includes Kendall smoothing, local polynomial regressions nearest to like k nearest neighbors, so regression, etc. So here we have nonlinear regression algorithm. So in this nonlinear regression encompasses various types of models that capture a relationship between the variables in a nonlinear manner. Here are some of the types. So we have the polynomial regression is one of the type. In previous lecture, we all discussed about it. So polynomial regression is a type of the nonlinear regression that fits a polynomial function to the data. The general form of the polynomial regression model is. So this is the equation of that, right? So, expression is y equal to the dependent variable, x is the independent variable, and beta over 0, 1, beta 1 up to n theta is the parameter of the models, right? So, n is the degree of the polynomial. So, here we can conclude that the representative. So, in previous lecture also, we all discussed about this, okay? So, it is a very flexible method, but chosen to the high end degree for the polynomial can be overfitting, where the model fit the training data too closely and perform the poorly and new unseen data, okay? So this is a, data set which we can see here. So actually it is non-like data set, but here we can see it is also a polynomial data set. So using this non-linear, so it is a no relationship between here, like it forms like the data sets. Okay. So let's move. So here we can say in coding, we can see a basic example. So it is nothing easy. So you learn machine learning coding. So it is very easy. So I've already written the code. So it's no lengthy time. I will explain step by step. So here what we did first, we import math pandas. So we import NumPy for numeric calculation, for matplotlib for graph visualization, okay, visualization part. So from SQL pre-processing input polynomial features we imported and linear regression too. And we import some of the mean squared error and R2 squared error. Okay. So here I'm reading my CSV file. Okay. It is my local file. It is my path. I have a GDP data. I have a table like this. So I have displaying a few table rows. So year and their values from the 1960s. So a simple example data set. So from here I'm taking the figure 8 and 9, like 8 and 5. Figure size I'm mentioning here. And we take a variable as x original and y original and define years and values and we're doing the values. Okay. So we are plotting the x original and y original, and for y label we entered we labeled as GDP and okay GDP, and for X level we have the year. So okay, title as the original GDP. This is the title. So we are showing. So it is a simple base, like we show in the previous slide. Okay, so this is a normal. So from this, now we are now from here we are taking a plot of the simple logistic mode curve. So we are separating the curves. Okay, so we take some calculations here. MP logistics. So NP explain logistics, okay, minus logistic regression. So here we plotting again dependent variable, independent variable. Okay, so dependent is the independent variable, independent variable in a curve show. Okay, so it is the main part. It is the main part of the definition. So define a sigmoid function. Okay, so what you mean by sigmoid function? We all know that it is implementing the sigmoid function, the logistic function, that the maps of any real number value 0 to 1, right? So we take okay, so take two parameters like beta 1, like take two parameters like beta 1 and beta 2. Beta 2 has a intercept, okay? So assign initial value for the beta 1 and beta 2 based on the institution or estimation, okay? Assigning the values and then applying, okay? And this applies the sigmoid function to the original data with the initial parameter values. Okay, we have tried it. And now we can see we plot the again we plot labeling this plotting. So again we see that both data here. Okay, this and this data. Okay, see we can mix the data. We can see the initial data. So we want to mix this into the this data. So we want to find the normalization part. So for the normalization data, we take that x normalization, x original and max here. So here we want to divide the year and value, their respective maximum values. Okay. So uses the curve fit function for the science pi kit. So it is the curve fit function for the science pi kit and optimization for the best fitting parameters in the sigmod. Okay, sigmod function based on the normalization data. So again, we want to return it. So return the optimal parameter like popped. Okay, return the optimal parameter. Okay, here we are popped. Yes, we see returning the optimal parameter here. So when we are returning the optimal parameter and the conservation matrix of pivot con. So optimization is a estimation to return. Okay. So here we can see that now after that print the optimization value beta 1 and beta 2 from the curvation. So we are again assigning the x label as GDP, x label as year and y as GDP. We know the dependence and independence variable and title, and we assign some set of values here for label sigmoid fit and color has purple line. So we can see that assigning the values here. So this is a short code. That's why I'm explaining this code because we take screenshot of this lecture and practice this code. Okay. So this is simple and example code to understand better. Okay. Not is a widely used. So that's why I'm explaining in this type. Okay. So like this, we will consider a proper linear function. Okay. Like this, we can consider a here we can consider a proper normalization data of sigmoid function of the non-linear relationship. Okay. So like this here, so we converted using normalization form. We've connected the data to main data. Okay. So I hope you guys all are understanding about this topic of the non-linear regression. Thank you.